I think today's the day I'm gonna start it. Scrappy, you ready? Clear prop.
It's alive! It's alive! It's alive! It's alive!
It's physics, math, and engineering. Machine it, draft it, build it, test it, break it. Every time something new gets built, the entire world advances. Laying in bed at night, it's designing new parts, designing new suspension, designing new wings.
Hey guys, all right, for those of you who have never seen one of my videos, let me tell you what we're doing today. We're gonna fire up an engine that's going in a plane about this size, but this one right here. And it is a little non-standard. So I like to build crazy airplanes, and I like to go after world records and try unique, different things in aviation, and then put on a parachute and go fly it. I like to do really fast planes, and I like to do slow flying, extreme mountain planes. This one is probably one of my most extreme. So what we're doing today is we're gonna fire up an engine, and to kind of put it in perspective, it's 780 cubic inches. That is nearly 13 liters. And for me, I have to go back to when I was 15 years old building race motors. I thought a really cool Chev 350 was a pretty big motor. And it moved a 5,000 pound truck. Well, if you took that motor and then another Chev 350 that moved a 5,000 pound truck, you squoze them together, you still aren't as big as the motor we have just put in a plane about this size that weighs less than 2,000 pounds. So we're talking something designed to move 10 plus thousand pounds in a little itty bitty bush plane. It's really not practical, but let's get it started. So I'm super excited about it. It's open pipe, it's loud, it's a drag machine. The engine actually usually goes into big giant crop dusters or into twin engines for moving a lot of people, and we shoehorned it in to something this size. So I'm excited, we're gonna fire it up for the first time. I hope you follow along. I like to build crazy machines. Let's get this one running. All right guys, I'm getting closer, and I think today's the day I'm gonna start it. So the exhaust isn't done, but I've got my old set of headers I made, and they're right here. These were a lot of work because I actually tuned them, which just means I didn't need, normally you might not see these loop back like this. The purpose of doing that extra work is to get the engine to run better, smoother, and actually you'll hear it in your ear. You might not know why one engine sounds different than another, but it's kind of like listening to a key on a piano, if it's right or it's wrong. One just sounds pure and one doesn't. And I'll describe why. And you can see it might be easier just to run this pipe and have it skip right into the collector versus return backwards. And what it's actually doing when I made this is it's timing up the pulses of the exhaust blasts that are coming out the exhaust valves. If you don't have them at the same length, meaning one's short and one's long, depending on the timing and which cylinder, an explosion can go off, and then right after it, the next explosion, because of the pipe length, they run into each other at the collector, meaning now you got two explosions merging together coming out the pipe, and you hear that in your ear, and it sounds different. It also creates a non-stable back pressure where normally it's one, another, and another. So what I've done by making those pipes is I've lined up the exhaust blast. So one goes out, and as it goes into the collector, right as it goes by, the next blast lines up behind it, behind it, behind it, behind it, and they draw each other out. So the back pressure stays the same on one cylinder versus another cylinder, which makes the engine more smooth and more pure. I think you'll hear it when I fire it up. It's a lot more work. I'm gonna buff and polish these up. It is scrap parts for Scrappy. This came out of the racer. for today, I just cut off the end. I'm gonna put some kind of hokey little downspout on it because I'm not gonna finish making these right now. I just want to fire it up, so I'm going to tip the pipes down so I don't blast my firewall. And if all goes well, let's start this. So I'm starting to clean up my mess, tying in all my EGTs and CHTs. So I'm going to put one on every single cylinder. I've done something I've done on all my planes to prevent the wires from getting strain on them and pulling apart just with vibration of flight. So this bar you see right here is actually just a really thin wall hollow aluminum tube that I had anodized. I've hooked to my cylinder head lockers I machined. And this way, when I get all the wires done, I have something rigid I can zip tie to so that there's no strain and I'm not just hanging the wires on all the other wires. I mean, it does work and people have been doing it that way for a long time, but I kind of like hanging the wires from a bar and then letting each one of the wires just sit loose, so it doesn't, the weight of all of them don't hang. Right now there'll be 8 sets on this side, 8 on the other. I'm only a quarter of the way done. Let's get back to work. So I'm getting the cables hooked up now, and I want to show you something really simple, and I only point it out because it's happened twice where someone asked me some advice about their engine and why it was running a little off. And what I mean by off is they get in turbulence and they thought the engine was going up and down in RPM, and they thought there was something wrong with the engine. And what it was is they had their cables, they didn't give them any relief where I've got this bending down and back up coming into the side of the engine. And so as the engine hits bumps or heavy G's, or they pulled heavy G's, it was actually putting a little tension on the cable and pulling the throttle. So they'd go on the bumps and the engine would pulse with the bump. So make sure you get a little relief in it. The other thing I like to do, if possible, it's not always possible, I always try and bring the cable out in line and closer to the center of the motor mount. This is a little bit low of center, but the closer you can get it, and then of course in line is better because you have less kinks. But the closer you get it to the center, the more the bumps, the less the movement in the cables. I'm just tying this in, but now I'm getting to this corner over here where I've got to turn and go over to the mixture and the throttle. And so I machined these up out of stainless steel. They're on ball bearings and they're really smooth. Rather than just a bushing, I actually did ball bearings, press fit, and then machined little spacers that gave the space I want. This will bolt into the bottom here, and that way as I'm going around the corner, rather than bending a cable, I'm going right to a solid fixed point off a solid fixed plate that's mounted to the oil pan. And then this has no drag. I mean, I can put all the pressure I can physically put on it and you can't feel any drag with the ball bearings in it. So one will be the mixture, and I don't know if you can tell, but they're all different lengths, so long and short. And what I've done there is sometimes you'll get a throttle and it has a tiny bit of movement, and that's kind of hard to fly in the bumps because a little bit of throttle movement moves the throttle from 0 to full. And other planes, they got the other way around where the throttle's got to go a really long ways. And so what I did is I set up the throttle back here and matched the pivot fulcrums on the corner. I used the corner to adjust my throw. So what will happen is my throttle here will use approximately 90% of its full throw. I don't want 100 because I want to make sure that it doesn't stop at this bolt or this bolt. I want it to stop at the throttle body. So this is going to come almost to the end and touch, and almost to this end and touch, but it won't touch that bolt. It's going to touch the stop at the throttle body. Same with the mixture. And to get that right, since they use different pivot points and the throw at the throttle body is different, these are all different lengths correspondingly, so that I have even throw all the way around on both levers and it's not just tiny movement. So anyway, it's a bit more work to just make that extra step, but it feels good. So I'm gonna put it in. Once I get around that corner, it won't be a cable, it will be a solid bushing rod that connects it with no play. So you will not feel any play in my cable at all. Anyway, I'm gonna get this installed. Let's get back to work. Yep, I found it. More scrap parts for Scrappy. All right, guys, I got my scrap piece of wire. The wire I pulled out of the box was actually from my engineering firm a few years back that I sold. It was a wire for a 600 volt battery pack for an 800 horsepower electric hybrid truck concept design that we took to the Detroit Auto Show. It was the right gauge I needed, perfect shape. I just needed to shield it. So I quickly used some heat shrink, two-stepped it. So the first time I heat shrink was after I crimped the end, I heat shrinked the end to the wire itself. Then I sleeved it, and then I got a longer piece of heat shrink, and I heat shrink from the other heat shrink 3 inches overlap of my protective abrasion shielding. So, and this heat shrink has a little bit of a hot glue in it. So as it melts, it actually melts into the weave of my sheathing. So you can't pull it out no matter how hard you try. It's actually become part of this protective sleeves. On a wire this big that can carry this many volts, the last thing you want is it to get an abrasion through it and then hit the start button and literally weld something. So this is my last scrap part wire that needs to go in the plane before I can hit the start button. Let's get to work. Okay guys, I'm getting ready to start this up for the first time. So assuming it starts, what's gonna happen is we're gonna blow a whole bunch of smoke. I pickled the engine and I filled it up with a fogger oil into all the cylinders. So we gotta blow that out. So I'm sure it's gonna cough and sputter, but let's cross our fingers that it starts. Woohoo! Please work. Why is it it's always in the middle of the night where starting an engine up for the first time? That's when you work. Good point. You guys clear? Clear. Clear prop?